In this video, we're going to talk about a rule called the empirical rule. Now, when histograms with a single mode are approximately symmetric, we also refer to them as bell-shaped. And so there's a lot of things that we can do whenever things are bell-shaped. One of them is using the empirical rule. So when the population that has a histogram that is approximately bell-shaped, we can say that approximately 68% of the data will fall within one standard deviation. What that means is that 68% of the data will fall between your mu minus one standard deviation and your mean plus one standard deviation. At the same time, approximately 95% of your data will fall within two standard deviations. So 95% will fall between the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation. All or almost all of the data will be within 3 standard deviations. So almost all your data will fall between the mean minus 3 standard deviations and the mean plus 3 standard deviations. Now I want to look at what it looks like on an actual histogram. So if I draw a histogram that's approximately normal, we're going to draw it similar to this, where we have a single mode area here. What our empirical rule says is that if we look at this, recall that the mean is in the center of our approximately symmetric or bell-shaped histograms. Now if I go out one standard deviation, the mean plus one standard deviation, and the mean minus one standard deviation, and I do that for 2 standard deviations as well. So I have the mean minus 2 standard deviations, and I'll do the same thing with 3 standard deviations. The mean plus 3 standard deviations. So what the empirical rule tells us is that between this value and this value, 68% of our data will fall. So between these two values, 68% of our data. Then it also says that between this value and this value, 2 standard deviations away, approximately 95% of our data will fall. And notice that includes the 68% already here, and then we add a little bit of portion here to come up to 95%. At the same time, between this value that is 3 standard deviations away and this value that is 3 standard deviations away, we're going to have all or almost all of our data. We may not have all of it because we may have an outlier, or we may have just a little bit left over, but almost all of it is going to fall within 3 standard deviations away. So let's look at an example of how this would be helpful to us. So in this case, we're looking at SAT scores. And the national average for mathematics SATs in 2011 was 514. Suppose that the distribution of scores was approximately bell-shaped and that the standard deviation was approximately 40. We want to know within what boundaries would you expect 68% of the scores to fall? Well, since this is bell-shaped, I know that I can use the empirical rule. And we're looking at 68%. 68% is within one standard deviation of our data. So if I, first of all, look at my histogram and I say, okay, I know that here's my mean, which is 514. And I'm wanting 68%. Well, 68% is one standard deviation away. So I'm going to take 514 and subtract 40. When I do so, I will get 474. I'm going to do the same thing on the other side, except for instead of subtracting, I'm going to add 40 to it. And I will get 554. So according to the empirical rule, 68% of the data scores, so 68% of the SAT scores for mathematics will fall between 474 and 554. So we expect 68% of the scores to fall between 474 and 554. Okay, that's if it gives us the percentage. What if it is actually looking for that percentage? Such as in this example, we're still using the SAT scores. So the mean is still 514. What we want to do is find out what percentage of scores would fall above 594. So in this case, if I start out by drawing my histogram, and I put 514 in the center, because that's my mean, I can calculate my 1, 2, and 3 standard deviations away. So one standard deviation is 514 plus 40, which gave me 554. Two standard deviations above would be 514 plus 2 times 40, which would actually be 80. So that gives me 594. Let me write that a little bit clearer for you, hopefully. 594. And then 3 standard deviations is 514 plus 3 times 40. So 3 times 40 would be 120. And so therefore I get 634 as my 3 standard deviations above. I can do the same thing on the other side, just so that I know what I'm doing. This would be 514 minus 40, which we saw a minute ago was 474. Here is 514 minus 2 times 40. So subtract 80 basically. That's 434. And then here is 514 plus 3 times 40, or add 120 to that, or I'm sorry, subtract 120. That should be a minus sign in there, so let's change that to 514 minus 3 times 40. and I get 394. Now, based on the empirical rule, I know that between 474 and 554 is 68%. I also know that between 434 and 594 is 95% of our data. So this is talking about the middle 95%. But we want to know this above 594. So we want to know this portion here. Well, the nice thing about this being symmetric is that if I draw a line straight down my center, that tells me that 50% of my data is above and 50% is below. It also tells me that each one of these spaces here is equal. So if I look at 68% and divide that by 2, that's telling me that 34% is between 474 and 514, whereas 34% is between 514 and 554. I can do the same thing with the 95. 47.5% is between 514 and 434. That doesn't mean this little bitty portion is 47.5. That means this entire side here is 47.5. So what that means is that from here to here is 47.5, and from here to here is 47.5%. So if I want to look at this little bitty portion, that's going to be 47.5 minus the 34, which will give me 13.5%. 13.5% here. Okay, this does really help me figure out what portion is here. A couple of different ways I can figure this. I can recall that this whole side is 50%. And I can add these two and subtract from 50%. Or I can look at this as being 95% in here. So what's left over is 5%, but that's 5% on both sides put together. So I would have to divide that by 2. So the easiest thing to probably do is to take 50% minus your 47.5%, which recall is from here to here, from the mean to 2 standard deviations away. When I do that, 50 minus 47.5 gives me a total of 2.5%. So this area is 2.5%. So we expect 2.5% of the scores are expected to be above 594. Now, one thing to remember is that the empirical rule can only be used if the data is approximately symmetric or bell-shaped. There are other items that we can use if it's not, but the empirical rule can only be used for the symmetric or bell-shaped histograms and data sets. Try some of the practice problems with empirical rule and ask me if you have any questions.